The propensity for water to resist overflowing is called surface tension. Intermolecular forces of the water molecules cause them to minimize their surface area and be closer together when exposed to non-water molecules. This is why there will be a curved, skin-like surface at the top of the water. We can prove this by floating a bottle cap in the glass. No matter how hard you try, the floating bottle cap cannot be moved into the center by simply positioning it there. Due to the curved surface, it will always float to one side or another. However, if you overfill the glass so that the level of the water rises above the rim, but without spilling out the sides, the bottle cap will actually center itself and stay there. This is because, like a suspension bridge, the water is suspended by the edges of the glass due to surface tension and the middle sags downwards. If you were to place a towel on the same surface, the center of it would sag when wetted with water. By balancing a needle on this bottle cap, it instantly becomes a makeshift compass. Magnetic fields exert a torque on the needle, pulling each end of the needle towards a pole, depending on whichever end is more magnetic. Even if you mess it up and stop it from rotating, it will always go back to aligning itself with the heavier end of the needle, pointing towards magnetic north. A compass needle's north pole is defined as the one which is attracted to the north magnetic pole of the Earth. Since opposite poles attract, the north magnetic pole of the Earth is actually the south pole. This makes the sharp end of the needle the end that is pointing towards the North Pole.
Okay, so my mind capture is about a shape charge, which is basically a way to focus an explosion so that it goes through something um, as best as it can. So here's a control test of a firecracker blowing up a styrofoam plate just strapped to the styrofoam plate. As you can see, the damage is noticeable, but certainly minimal. The hole is small, and the styrofoam plate is intact. For this next test, I wanted to create something that I would do if I was trying to create a bigger explosion without knowing about how a shape charge works or the physics behind it. In this test, we shaped tin foil around a firecracker to try to condense more of the energy towards the styrofoam, and you'll see the results here in a second. As you can see, the hole is slightly bigger, but really the explosion that occurred from the foil on the cracker and just the control test are pretty equatable. So I don't think that the foil really focused much of the energy. What you're going to see next is my creation of a shape charge, and basically it constitutes a bag of water in front of a firecracker that's lit and then does considerably more damage. So I'll let the video speak for itself. As you can see, the new explosion separated the styrofoam plate into 3 sections, where before the control test only put maybe a quarter size hole through the styrofoam. I want to reiterate that the only thing that has changed from my control experiment is my introduction of the bag of water in front of the firecracker. So in the upcoming sequences, I'm going to explain to you how a shape charge works and where in the real world this technology is implemented. A shape charge is an explosion which travels through a substrate and over a cone. This cone becomes inverted and creates a point of super penetrative force, highlighted in red here. The way I created a shape charge was by putting a rubber band around the bag of water. This created a conic section to the bag. This conic section, coupled with the explosion of the firecracker, created this high-pressure stream of water which busted through the styrofoam plate. This was pretty rudimentary, but a great way to see a shape charge in action is the high-explosive anti-tank round and M1 Abrams fires. The upcoming is from a National Geographic documentary on the tank.
Heat rounds use an explosive charge to penetrate armor. At its nose, the charge has a sensor. When the sensor hits the target, it ignites the explosives inside the shell. This heats the copper lining of the charge to thousands of degrees Fahrenheit. The molten copper is compressed into a narrow jet that blasts through the armor at up to 25 times the speed of sound. The intense temperatures liquefy the metal in the armor, sending lethal shards of hot metal throughout the tank, hitting the crew.
The high-explosive anti-tank round operates on the same principle that my bag of water and a firecracker does. It's all a shape charge.
Bitch! You! Oh, yeah. Wait, no. Just can't be real. Hey, what is this? Sorry. Keep it rolling, keep it rolling.
The tuning fork and water experiment. When a tuning fork is struck, it causes the molecules in the air to vibrate and bump into one another. When these molecules reach our ears, we hear the sound waves because our eardrums vibrate. But we cannot see the waves travel through the air. But when we test the same effect in a more dense medium, such as water, we can actually see the waves being created. As the tines simultaneously move inward, they create compressions or high pressure zones where air molecules pack very tightly together. When the tines stretch out, they create refractions or low pressure zones. The combination of the two is what creates the waves as the tuning fork vibrates.